Alright, time for another DraftScience video presentation. My effort to communicate reasoning for you to perceive that the world as described by the masses, and the one described by the professionals, are neither one of them makes any sense. Realistically, that there's this reason people believe, and the reasoning is not good. So, as fair context, I do watch Modern Mystic videos, and he did mention an Adam Curtis documentary that was in some way worth the time. 7 hours or something worth. I like him. I like the, it's a good little show. It's good to jump cutting and flashy bits and all that kind of stuff, but it's the irony is the flashy bits are all intended to make the argument that you people are all manipulated by flashy bits. So he's using flashy bits to inform you that your brain is a piece of shit and can't reason worth crap, and logic doesn't mean anything, and it's all about motivating you through flashing the right images in the right order, and therefore I have controlled your behavior and how you think and what you will do. And so I find that a little bit ironic that he's using the very instruments of manipulation that he's warning us to be wary of the manipulators. While I manipulate you with manipulation. Yes, be afraid of the manipulation as I manipulate you. Anyway, so that is a context you can't get past. It was, I would argue, I wasn't very impressed that the whole thing was just a big, drawn-out, theatrical, very little substance beyond just saying, hey, people are gullible. Yeah, we all know that already. And they'll fall for almost anything. And their choosing of the sides is done very poorly. Just the sad truth. I really just, I just don't want to get into the whole philosophy discussion here. So I'll try to prevent my brain from going where it doesn't need to go, beyond saying this is a real dilemma in terms of communicating with people, if this is necessary, because it's just something I just couldn't care less about, is trying to appeal to emotion or trigger identity. I'm on your side. Come on, I'm with you. We have the same heroes. We have the same. We can use the same images to, represent good and evil, and somehow match our intentions, and therefore match our goals. And this isn't good. So I don't want to do that. I think people are intrinsically logical. I think they're intrinsically, fundamentally, mechanically. They have a sense of, winning well. That's really the cool part. And if you have to cheat, you're going to feel like a cheater, and that's not very cool. So there is an innate bit in the system that does force a certain kind of integrity. I think that's how we socially succeeded for millions of years in tribes. It was that there had to be some honor built in, and and all of that sort of has gotten diluted and weakened, but I think it's still there, and I think you can still reason with people without getting, without layering it all with symbology and totem poles. You can't motivate them without the sacred totem pole. The iconic image, the whatever. But that belief is thin. I guess it's partly just based on the fact that that's how I work. I mean, my brain has always been able to tell the difference between something that looks sincere and something that doesn't. Something that has all the earmarks of being manipulation or cheating, and things that had strong, well-built integrity. The difference between the redwood tree and the, whatever, poplar bush, whatever. There was, you could see these differences, and recognize, the value of the truth. I mean, that's another one where it's just that should be the icon, is the truth. Well, anyway. So in that context, it certainly was depressing. Just because it just, oh shit. Maybe it does come down to that, and this is a hopeless task, reasoning. And people are team players, and they really are glued to their team and their icons, and they can't accept any, they can't acknowledge that they might be on a team that isn't worth belonging to, or be a member of a club that is nasty and cruel, or that is blah blah blah. That lacks integrity, and they'll just become defensive. And there's every evidence that that's all that's taken place on this channel so far, is the defensive overreactions. Clearly the extent to of people's objection is just so out of proportion. As if I was pointing a gun at their child. But that's sort of understandable from my own perspective, because I have metaphored my what I have discovered in my life, the observations I've made. Some of them do feel like children. Some of them feel like a possession, and something I'm responsible to help through the world. I put it here, and I'm going to defend it, but it does have integrity, and it should be appreciated, and it should be valued, and I'm going to help preserve it until that happens, kind of argument. So in a sense, I'm reacting also. But anyway, so yeah, this is all the psychobabble part, but I mean, apparently it has to be part of my thinking in terms of trying to understand how apparently I am triggering people in ways that isn't conducive to my purpose, but I don't know if that's really avoidable. So, I'm stuck with a bit of a dilemma in terms of, if you have to dress the truth in, a tutu, and have it spin around and dance, a particular way, then it's not the truth anymore. So anyway, so context. And so these comments are sort of, it's better. I mean, this is an improvement, but I don't know. Anyway, so this Mike Holden. Well, anyway, sorry, just trying to understand what you're saying stuff different from what they generally teach, and teach you, and I'm not a scientist or even very science literate person whatsoever. Right, that's sort of part of the problem, but it is, frankly, my physics is so understandable that I don't think you don't have to have a huge math, that's for sure. You don't have to do all this mathematics. You can just do the conceptual stuff. I can draw a picture of it. So it is not that hard to follow along in some respects. But I like to shoot and gun people talk about this stuff a bit, but yeah, you're not measuring it for science, not tracking total energy. Good. I'm glad you understand that part. That the arguments people interested in ballistics are having are arguments, again, just about, obviously your accuracy improves if you can reduce the recoil of the gun. It's just a fact. And different things, and so that's what they're balancing different effects, and it's just not in the sense of a scientific question. It's a pragmatic, what's best for you as the individual. Even some people are going to be, like a woman, for example, would be better off with a different gun than, say, a man, just because of her body mass and her capacity to withstand recoil. Anyway, so at least this part was nice. Not tracking total energy at all. Momentum is key, I guess. So mass being just as valid. So he's getting that part. That's super intuitive. Well, that's the funny part, right? There's all this resistance, and yet that's that keeps it simple, stupid. And yet the simple answer isn't the answer that people find appealing, which is disturbing. That I have to go through all this effort to say, why would you think it makes a difference when we sort of can demonstrate in experiment after experiment that it's energy in, energy out. You just follow the energy. You can't you can't lose half of it to, I don't know, heat. Just some invented function that you don't notice taking place. Nor can you gain free energies. There's this formula that needs some scrutiny. Now I'm wondering, their formula. Now I'm wondering, what is the purpose of the other formula? LOL. Again, the purpose isn't seen for its, that it was a right answer ever. You see the purpose in the fact of when it was invented. And the fact is, they didn't know a lot. They didn't have atoms. They didn't have electrons. They didn't have protons. They didn't have an understanding of magnetism at all. All they had is outcomes. They had effects. Just like gravity. They had an effect, and they had absolutely no clue what was the cause of the effect. And all they could do was make, kind of bizarre guesses at it and such. But they didn't have any. So it was an environment of ignorance. It wasn't the purpose wasn't to answer questions accurately. The purpose was caught up in what people wanted to believe about the universe and this whole idea. There was a ton of ideas that Leibniz, the inventor of the instigator of it, believed. He believed it was it was actually living beings all the way down, that living things were made of living things, and everything was made out of these corpuscles of living thing. He uses words like monads and solitons, and this isn't it's not very good science talk. And so the purpose was to answer a question, or to resolve something that wasn't intuitive. So again, the gravity thing wasn't intuitive, because you throw two things and you have this weirdness that the light thing does go farther, and going farther seems to a lot of people that, well, you must have more energy to go farther. It's the same intuition that just says, when Galileo discovered that the heavy thing falls at exactly the same rate as the light thing, and the only thing that's screwing it up for us in terms of observation is the atmosphere, and air resistance. But in theory, they're not doing what we would think they would do, or that would seem the simplest. The thing that has so much more power doesn't seem to be going faster as it should, because its power is in its mass. And that's the part they hadn't been able to figure out, is the fact that the forces and the mass are left and right hand kind of things. They're not the same thing, and that the only way the forces can interact with the forces is through the matter, and the only way the matter interacts with the matter is through the forces. And little key understandings like that they didn't have yet. So they made bad guesses, and once everybody jumped on a bandwagon, it was embarrassing. Okay, if you had to jump off, it was embarrassing to switch sides. But even that is sort of a funny part because Leibniz said things in his early career, and then directly contradicted them later, and uses the exact opposite arguments in defending his theory. So earlier he thought theoretically that his understanding of motion was so unconnected to mass that he thought that theoretically the tiniest little speck of dust should be able to give momentum to the giantest of boulders. That your movement had nothing to do with mass. That movement was a little little spiriton thing, and that the whole essence of something moved, and it wasn't some process that took place that forced something to move. And that's just a limitation of our vision. We watch the universe at a very slow frame rate. I mean, the universe is running so many pictures per second. I mean, so many events per second, and we are seeing only one tiny little piece of the outcome. Billions of frames go by. Billions of years in a sense, and we don't see any of them. We just see the tiniest of outcomes, little changes in the environment, but we don't see that all of those changes are made out of billions of operations, billions of functions, just like this computer is recreating my image in this digital form, creating the illusion of some kind of analog signal, and it's nothing like that. It's just showing you images, static images over and over, different images, flashing the different images. Tons of process for an outcome, for every second of my existence on the computer is made out of a million operations, a billion operations. We're not seeing all that. All right. So the formula didn't really have a purpose, and I would argue, it was just a challenge. The whole purpose really was this idea that these were, it's a political argument in a sense. Leibniz obviously didn't like Newton, and then he didn't like him even more when Newton caught him stealing his calculus. And so there was huge animosity between them. And, that's really all this is out of. And again, Leibniz didn't like the whole idea of how godless kind of Newton's physics was. And, so there's lots of, I can give you explanations, but again, is there any, will they work on people? Are they useful in them understanding the context? And so there wasn't some question that needed to be answered besides the fact that a few experiments create aberrations as results, and they confuse people. So I've tried to say, if you look up something called a ferrocell, okay, it's a little LED device with a couple pieces of glass and some ferrofluid mixed in it, some magnetic liquid. Magnetizable liquid, I guess a better way to say it, and it produces results that are stunning visually. They just whoa, but they really don't mean anything scientifically. Scientifically, it's completely a bizarre exaggeration of the mechanics of what's happening have nothing to do with what the image implies. And that happens, okay? So you can have experiments that do something like, again, doing experiments with clay or ballistic gel, or you use certain things, and you can get outcomes that just don't fit all the other outcomes as well. And that's where that creates the fuel, okay, for the conspiracy theory, if you want to call it that, the counterculture to exist on. They'll feed on anything that's aberrant. They'll feed on one statistical aberration, and they'll feed on it. They'll jump to the conclusion that something's been proven. And But yes, so the purposes all are not good ones. The story isn't a good scientific story. It's a story of how science goes wrong. And, and I'm just sitting here with a bit of surprise that reasonably intelligent people, okay, I mean, they have been educated, and they can't get that could have happened. They can't figure out that, yes, when you really look at it, there's no real good evidence supporting this notion, okay, that velocity is more important than mass in deciding how much capacity something has to affect something. Every indication, every experiment sort of just demonstrates that if I double the mass, I double the capacity of the thing to be significant. That whatever is going to happen, the mass is integral to the happening. And all the evidence points to that. And there's certainly no idea of a squaredness. I mean, this idea that it goes, 4, 9, 16, 25, that it grows in this exponential way. And, no good reasoning to defend any kind of notion that the velocity makes that big a difference, these huge, gigantic differences. And clearly in all I've given the examples, I mean, the real world, we don't see this formula being realized by people and then behaving accordingly, buying lighter cars and, using lighter bowling balls and, lighter wrecking balls and all of that stuff. We don't see that happening because, frankly, there's just no truth to it. All right. So, good in the sense that he's sort of, he's not committed, he's not confident, but he has accepted that's, what you're saying seems right. Okay, so I'll play along, so that's good. And then this guy decides to, the guy's already convinced, so why mess with it? But he has his purpose too, I suppose. So he says, Gary often doesn't use math examples. Well, because I don't believe in much of the math in a sense. As soon as the formulas, I've pointed out, as soon as it gets a little bit, as soon as they have played with it a little with replacements, it loses a lot of its credibility. Because, again, they have tried to say that this equals this in one circumstance, and then they've tried to apply that equality to all circumstances. So it's like, you could need to be 6 feet tall to get onto a ride somewhere, some very exclusive ride. You know what I mean? But more higher than 5 feet, or you can't get on the ride. So in a sense, everybody's called equal who's above 5 feet. It doesn't mean all the people above 5 feet are 5 feet tall. It doesn't mean that they're all the same weight. It doesn't mean a lot of things. And so I'm just saying it's very dangerous when they do these classifications for these purposes, where they do all these replacements and say, well, A equals, velocity over time, and, no, it doesn't. Because in other circumstances, the velocity isn't going to have anything to do with taking it into segments. The velocity is going to be imposed in a millisecond. There's not going to be any apportionment of velocity over a continuous amount of time. Time isn't going to have anything to do with once you acquire the velocity. The acceleration is so short that you really can't dissect it into portions and then say how much of the portion of the trip. And again, it's not even the whole trip. Once it has the velocity, the acceleration was a tiny portion of it, and you're still assuming that the acceleration is happening through the whole length of the travel. Those kind of things. I'm just saying this isn't continuity. It's just manipulations. They have an end. They want to make this number equal this number, and they find a way to make them equal each other. Or this symbol equal this symbol, and they find a way. They find a pathway where they can make the two things equal even when they're not. All right. Anyway, but his contention is that energy should be the same whether it is 2m 1v or 2v 1m. No, my contention is that they had the right answer, that Newton gave it to them, Descartes gave it to them, in the sense that this was a clear definition of how you understand how things interact in the universe is mass and velocity, and especially in the big universe, it's just all over the place that works. It gets you right answers. If you want to predict where something will be through these interactions, you just use this mass velocity relationship, and it will tell you where it will be and what will happen. And it'll do it very well. Okay. Since kinetic energy formula isn't harmonized, so that's not the right word to use. So I don't know. What do you mean harmonized? It's in complete contradiction. It answers the question with completely different numbers and creates a completely different universe. I mean, there's no doubt that if you use them to predict, one of them predicts very different outcomes. If you use one to decide how much thrust to shove out your rocket engine and use the other, they'll get different answers. You will navigate the universe differently. They can't harmonize. Yeah, because they're contradictions. One of them has to be right and one of them has to be wrong, or they're both wrong. I would argue that there's no reason to believe they're both wrong, because we already know momentum always gets the right answer. So again, there's just no reason to argue with momentum, except if you refuse to understand how, when we try to catch energy, it's a little tricky. What we're using to collect energy, the devices we're using, can give you deceptive results if you're not understanding how much heat that device is capable of creating, or how much sound or vibrations or other things, where all the little subtle frictions are. That is, the transfers you can't see. So if you're not aware that some mediums create transfers that you don't see, okay, that you have to measure them with other devices, then momentum can be stated to fail in certain experiments. But I mean, those failures are completely understandable, and even Leibniz understood them. I mean, his whole explanation for the clay hitting each other was that the momentum the energy isn't destroyed. The clay is moving in all kinds of other directions. So he had already started to find the connection between big movement and the creation of heat. He didn't say heat, but he already had the idea of you're moving other bits inside of it. That everything's made out of more bits, and the bits are moving. So, I mean, this wasn't an unknown concept. But they just didn't have enough of that put together. Again, I've already pointed out how this trial didn't take place the way trials need to take place. It was a trial in, there was this public spectacle, of competing intellectuals arguing with each other from thousands of miles away, and, through papers and publication, and through even private arguments. And it wasn't, the way it should be. It wasn't a good trial. And so the right answer wasn't chosen. This might be, let's see, Gary's view is it should be discarded, and that the true measure of energy P is our momentum. So again, I'm not asking you to discard something. I'm asking you to preserve what was already proven to be reliable. So I'm asking you to don't fix what ain't broken. To take off of something a silly dress you put on it. This, you're the ones, the thing you've created is the thing that hasn't been defended. Okay, I don't need to defend momentum because it worked, and Newton was right, and everybody knows it. So I shouldn't even have to make this argument, frankly. You've just imposed a silly mistake on the truth, and again, there really isn't a good reasoning. There's not a good trial where, you did it all and you convicted them correctly. This didn't even take place. Anyway, this might be abstract, so here are simple examples using kinetic formulas. So I don't think he needs these examples. I have written down this much math. So again, for you to say I haven't done math, well, of course I did do the math. Enough of it. I mean, this isn't brain surgery math. And I pointed out how you can rewrite the formula VMV over 2 there. And if you saw it for what it really is, then maybe people would realize, well, why is the V in there twice? That just doesn't seem to make any sense at all. Why would you derive something like that? How can velocity spread into dimensions. Again, the key to things being squared, like ours being squared, is because of the fact that it's, the dimensions things can move in. And the fact that the circumference of the circle by a squared ratio gets bigger and bigger as you just double the radius, you quadruple the spherical surface. And so those relationships exist in nature, but there's no reason to think velocity has any capacity to do these things. All right, so he goes through the whole thing, just points out how, yes, the kinetic energy formula says there's twice as much energy in this circumstance. He could write other circumstances where it's 100 times more energy. And momentum says, no, the two objects have the same energy. And then the bottom line, he says, this is not my view. I'm simply steel mining Gary's view. So I don't know what that means, steel mining. But anyway, Manning. So my question would be, well, what is your view then? I mean, why don't you argue your view or argue your position and defend it if you have a position? So it's, it seems bizarre to me. You have a counter argument, then make it. I mean, again, where does momentum, show me one experiment where momentum fails to get the right answer? Show me one physical circumstance where if I just follow the momentum, I'm going to get the wrong answer. I'm not going to understand the energy and its migration through a system. If I just follow the momentum, and we know the momentum is heat, we know the momentum is sound, we know the momentum is all those things. If I move anything, I have to use my momentum to move it. If something else jumps off of me with momentum, okay, it means I had to give it that. All right, we're talking about energy in, energy out. We're just saying, okay, it's not because this thing came into me and bounced off me. No, we're talking about if I change something's momentum, the change has to be part of me. Either I absorb what it has or it absorbs something I had. But change can't take place without me creating the change, so to speak, me being part of it. And that always works. So, I mean, sound is not a reflection. Sound is, an impulse pushed into the environment. It's an addition of pressure. Heat, you can say, heat isn't a reflection. Heat is more activity. It's more velocity. Something can't have more velocity. An atom hits me and it leaves with more velocity. It can't leave with more velocity unless I have lost some velocity. So I have to lose it for it to have it. And, that simple understanding of conservation means there's just no way to do this. Two objects interact and one of them ends up with twice as much energy as the original condition. You can't. I mean, Leibniz argued against perpetual energy. And the irony is that nobody presented him a thought experiment that demonstrated how his theory is perpetual energy. The simple argument that all you have to do is store the energy in some other system, and you can point out obviously that you're created perpetual energy because all I have to do is replace a heavy thing, let a heavy thing transfer its energy to a system, and then replace it with a light thing and let that same energy propel it. And I'm going to find that I've created instant energy. I'm going to have twice as much energy as I started with. All right. So that's it for comments. I was going to do a little bit just to connect, how this failure to get this right probably led to other failures in terms of perception. And again, the context is so somebody reasonable should be able to admit that physics was cobbled together. This wasn't like a shoemaker with years and years of experience who was making the shoe. The shoe of physics has been made by people, who didn't even know how to make a sandal, and that's what it starts with. And it's just passed down to people that can add, I know what a button is, so I'll put a button on it. And another guy, so I know what a lace is. I'll put a lace on it. I know what, I know this rubber's harder than that rubber, and I'll put, harder rubber. And so it's just kind of, there's very little context, very little vision of the past and the future for each step of the process. And so, they're gluing things together before they put the lining in, or they're sewing something tight, and, they never, put the insole in, or so, what I mean? So things that were done in the wrong order. The process is sloppy. It's a really messy recipe, and that's how you get ingredients put in twice, like velocity. It was a really messy process of this evolution of what they call physics, and they never really did. They never had the convention. They never had the where they took a year or two, and instead of spending billions of dollars on silly crap, spent some time and money just going through the bits of their physics and seeing the parts that are, incompatible, and fixing it. Like bent space and quantum mechanics and those kind of things. No real effort to invest any energy in figuring out how, recognizing that that's a real problem and they need to fix it. That kind of stuff anyway. Just the whole perceptual thing of just recognizing that there are facts out there that are telling them the truth. The speed of force, for example. It's not the speed of light. It's the speed of force. Those little fixes mean a lot in terms of continuity and understanding that forces aren't doing what light is doing. Light is doing what the forces are doing. And that means gravity is doing what forces are doing. That gravity and light have something fundamental in common. And you can't keep thinking of bent space. Light isn't bent space. That just doesn't work. It is momentum. It gives things momentum. And gravity is obviously doing that obviously also. Obviously gravity is imposing momentum. Why would you think it's doing it through some magical, spooky action at a distance way, when there's every reason to think it's doing it exactly the same way light does it, except you can't see the light. Okay, you can only see what the light does, but it does it. Right in front of you. Bent space, come on. Too silly. All right, well, I'll take a little pause and maybe talk about that a little bit more. And, and I have to, if this isn't going to be an argument, okay, I mean, if it's not really possible to convey information to people in some sort of ordered process of making a reasoned argument why this is a kangaroo court, why you're doing the whole legal thing wrong, you're doing this trial terrible, this is a terrible way to run a trial of the truth, and that the jury really should be persuaded by the evidence, okay, not the hairstyle of the defendant, not because, the lawyer is dashing. This is a terrible process if that's what you think should be deciding the truth. It really should just be the integrity of the arguments and the evidence. So again, if you believe, you should believe because you've seen evidence that it's been proven to you, not somebody just told you a story. Well, we did a single photon experiment with blah blah blah. And, did you see it? Did you believe it? Are you sure they knew what they were talking about? And the physics is full of it. In terms of at all the real fundamental places, they totally exaggerate the evidence, right? Like the Eddington experiment, never repeated with better technology. 100-year-old experiment, never repeated with better technology. 400 times better resolution from space, never repeated. I mean, these are glaring flaws in the evidence. This is like, they rubbed it on a DNA stone. It's not like they take to the DNA and did all the scientific processes to decide it was that guy's DNA. No, it's like they rubbed the DNA on a DNA rock. Well, the rock turned pink. So, This isn't the way you do it. People should all agree that this isn't the way it should be done. That the trial should be much better than this. That the evidence should be carefully presented and carefully scrutinized, and that this whole thing is just, again, this is just bandwagonism. You've just devoted yourself to something, you've invested in it, and you just don't want to admit that your investment was a little bit stupid. You should have been a little more careful, before you jumped on that bandwagon. Well, anyway. I mean, anyway, mood. It's all very discouraging. That you can't just argue the argument. You have to argue a bunch of other crap. So anyway, till the next time. Well, till shortly, because I don't think I'll just pause. Try to regain some enthusiasm. Alright, should be back. Get rid of that. Drawing device and such. And maybe we'll move that over to get rid of that metally thing. Alright. So, gravity. So as I've pointed out, it's just all about, this is really momentum. It gives things momentum. So it functions just like heat, or even the more mechanical things, bigger things, you could just understand hitting something and transferring the energy. And clearly that's what gravity's doing. It's giving something momentum. It's the same process, you can just argue. Just as the same process as an electron hitting inside of an atom and shooting a little bit out, and a little bit now has momentum, and it'll have interactions in the world by hitting other things and transferring the momentum. And so the momentum is always on the move. It always goes somewhere. It's all a cycle of transfers, and that's all that's happening is transfers. And then you can see it in the biosphere. So the biosphere sort of tells you, the thermosphere, you could even call it, where stuff is moving around based on buoyancy. And that's almost just like water. You could say, under the water, we could make this water, and these rules that exist for why things move which way in the circumstance. And it's really just about how much mass there is per square inch. So if I can make an object and I just increase its mass per square inch, all right, I don't know how to symbolize that. The density of the atoms, you could say that even. The atomic density will just tell you, it'll tell you how much of this it's going to be interacting with. Okay, that's part of the equation, and the other part of the equation is what's it moving into? Is it moving into something that has more density? I don't know how exactly to draw that, but and if it is, well, the stuff with more density is getting obviously more pressure. It's got more movement, and so it's going to be pushing that movement out. So it's all just about things getting more and more dense as you go further and further down. You get deeper and deeper, the density gets heavier and heavier, and there's a whole bunch of stuff that's still capable of being changed, in the sense that, water being the interesting one, where the water gets colder, it gets bigger, it gets less dense, so it has this, thing where instead of getting smaller as it gets colder, like most things do, it does this weird thing where it gets bigger, so it gets less dense, and then that causes a buoyancy problem. And so, but things are just cycling based on this mass, to space ratio. That mass is so critically important to how everything moves up and down in the atmosphere, and it's just about, frankly, density, because the heat gets into something, and what does it do to the thing? It expands it. It decreases its mass density, by spreading it out, okay? And so, yes, it becomes buoyant. It is less affected by gravity because there's less bits to hit per square inch in that area than there is in the area right next to it, where there's more mass bits to hit. and there's more pressure on this one going down than there is pressure on this one going down, and those differentials in pressure are going to mean it's going to rise. So it's like the boat or whatever, if you can put more air in the boat, okay, spread out, then the total density of the boat goes way down when you add the air that's inside of it. But if you fill the boat full of lead, well, then the boat just sinks. So you have to fill it with something lighter, so you can decrease the density and thereby decrease the amount of pressure down. And the fact is the only place you can go is up, because it just gets denser as you go down, denser as you get down. So the pressure can't go down, it has to go up. All right, and this sort of gets back to the, I've made the argument about waves, and that I would argue the mechanics of the wave. You can sort of see how the energy doesn't have a choice, in the sense that the water is moved, and the movement is in a direction. So you drop something into the water, and it evacuates the water in this direction. And the thing is that as it does that, it increases the density, the pressure. Okay, it's compressing the matter. It's pushing atoms into atoms. And so the density per square inch is increasing, and that increase is, to a point, needs relief. And so there's no place for the extra pressure to go. The thing can't go this way because it's already created high pressure here. The highest pressure would be where it's pushing into. And so it's got very high pressure here, and it's just now buoyant again, right? Because it's got higher pressure here and high pressure here. The ground, lower, you can't go into the ground. The ground is really hard, okay, so the pressure can't go that way. So the only place it has to go, it's like a buoyancy thing. It goes up, because it can go up into gravity, because it's, it's less dense than everything around it. In terms of the amount of pressure here is more than the pressure here. There's just nowhere to go. The pressure here is high because that's where the force is coming from. The pressure here is the ground, and that's already been pressurized over time, so that's higher pressure. And they're creating higher pressure right in front. So the only place you can go is up, into gravity. Well, the trick is, though, you go up into gravity, and gravity's going to, it's going to resist you making that change in the buoyancy, because the air around you is much lighter now, So now you're the heavy thing poking up into the light atmosphere. And so it's just going to be another buoyancy argument where you're just going to get pushed down again. And you don't have any choices again. You can't go down. You can't go that way, because that's obviously the pressure you're running from. So you go this way again. And then you just repeat the cycle of going up, and then you go back down, and then you go this way again. Because you really don't have anywhere else to go. And so that just repeats the cycle of transferring the energy. You're just transferring it from atoms to atoms to atoms to atoms that are in different densities. And their densities decide which way the energy can possibly go is going to be dictated by the fact that there's more energy someplace else. There's more density someplace else. And, and that's just showing you the energy doesn't die. And then eventually you lose some of it, because, yes, it starts going in other directions. It goes sideways. And all that sideways motion, that becomes your wave. Okay, is the sideways motions, so eventually it'll die out, because it'll all get moved into different directions. Even the sideways motions ends up going sideways and then sideways, and that ends up being heat. Heat is just where you keep changing its direction. You keep changing its direction. You keep changing its direction. You keep changing its direction, and then you end up with stuff going in all directions. And then slowly but surely that extra heat will be radiated out into the atmosphere and other places. But you can follow the momentum. You can follow the energy. You can follow the there's no room in here to be saying mass isn't important. Mass is only one half of the equation. No, velocity and mass. The velocity is essentially painted on the mass. If you have more mass to paint velocity on, you don't go as fast, because the paint is thinner. The velocity paint is thinner. You have fewer mass bits, you'll go faster because you're putting the paint on thicker. And clearly in gravity, it's just about each individual mass bit. It's an atomic. Gravity is a nuclear force. It affects the little atomic bits, and it gives each one of them the momentum. So they don't have to share it or cut it in half or do something else. I mean, each one of them's moving. And each one of them, when you add up all those little bullets, it adds up to a great big giant bullet. Okay? I mean, it's that's your total momentum is going to be the number of those things you have and how long they were being pushed, how many times they got hit by the force, how many times they get hit, how many times they get hit, how many times they get hit, and that's how fast they go. And everything goes the same speed because the things really moving are all the same thing. They're all electrons. The only thing ever moved by gravity is electrons and protons, and the electrons and protons are all the same, so they all move the same exact speed, and they're in the same amount of force. So of course everything just moves based on, everything moves based on what the electrons are doing. And if you have more electrons, obviously when you hit 1 square foot of space with more electrons, you're going to affect that 1 square foot more dramatically. Yeah. But in a way, understanding momentum makes it capable for it to understand gravity, to understand thermodynamics, and understand buoyancy. And if you screw it up, you create this bizarre notion that there's all this, living force kind of crap in here. There's no living force. If you make heat, you have to make it out of your momentum. If you make noise, you have to make it out of your momentum. So you can't say, I successfully transferred the momentum to another object, and then say, and I lit New York City, and I did something else with the energy. You can't transfer it to 2 places. You can only transfer one piece of energy, one piece of an electron moving. You can only transfer it to one other electron moving. You can't or you can transfer it to 2 electrons moving, but they have half the velocity. It's in these units. You can't make fake energy units. You can, but you shouldn't. There's no good reason to. Alright, so we'll call it a video. And such, yeah. It's good I'm just not getting, belligerently stupid counter-argument, but I'm not getting much concession either. And so until, I guess it's until an icon drops, until somebody who has some respectability, who's one of the pros, decides to do the right thing and say this is an argument worth having, that real scientists should make this clear, because it's not clear, it's mushy, it's ugly. It's an ugly duality of equations. You shouldn't have 2 equations claiming to define the same thing that get different answers. That's just fundamentally unscientific. And so I guess until that happens, there just won't be any energy for people to give a damn. And that's, again, bad on who? It's tragic, really. I mean, I wish I could be a viewer and say, wow, gee, that really should take place. I'd be thumbing it up and I'd be saying, hey, there's this guy who's, perfectly explaining why, physics is a bit broken and no one's paying any attention. Yeah. But we haven't got there yet. We haven't found that physics lover who says, yeah, it's about the truth. Yeah, and yes, he's made a very good argument that their truth is just creationism. I mean, that they have a religious theory right in the middle of their physics, and they really ought to fix that. I mean, I would think some science lover, some person, I've done it, I've gone to look at the little rover pictures. It's not very interesting, frankly. I'm surprised that they go to all this trouble to land this thing on Mars, and it hasn't done shit. It's just sitting there doing, looking at its feet. I don't know why it takes so long for it to get an agenda. It hasn't even picked up a rock and looked at it or something. I mean, nothing. And I watched SpaceX blow up. That was kind of fun. I mean, I saw when it was coming down. It was on fire. You could just see this obvious fire. But it's the whole thing is done so, rickety, that, the technicians are like just people on their home PCs or something, and they're like, well, yeah, it's land. Oh, yeah, successful. You're the man, Elon. You're the man. Yeah. And whatever, 3 minutes later, it blows the fuck up. And they just call it a big success anyway. I mean, it could have blown up before it landed, right? I mean, there's absolutely no logical reason not to recognize that the fact that it was on fucking fire was not a feature, okay? That was called failure. Being on fire is not a good thing for a rocket. I mean, in the wrong places. We already know that. We've seen that spectacularly, And so they just got lucky that it didn't blow up before it landed, right? It wasn't successful, But anyway. But, yeah, so if you're a science lover, you should really care about the truth, And, anyway, I can just reason with you. That's all I got. I mean, I think that should work, but apparently it isn't very effective, and that really is disturbing, that it really has to just be presented to you in some cartoon way. I have to take a bunch of images and jump cut between toilet bowls and, beautiful pastures and blah blah, and jump cut, and have the keywords associated with the negative things, skull man versus pretty girl versus this versus that, and just totally manipulate you into saying, oh, I get it now because you showed me a pretty girl. I mean, I shouldn't have to go there, but what should be really is a whole nother conversation. I mean, why humans are so reluctant to do the should thing. They should fix it. They should build nests. They should do things right. They should clean their rooms. Yeah. But they won't do it unless you ask them just the right way, with just the right candy. All right, anyway. Oh yeah, I have to do this one first. Okay, so this has been a DraftScience video presentation. Thank you for your participation, sort of.